management, effective communication. Okay, so I see Stephen Yang is remembering kidney heist. And I'm seeing another remembering kidney heist. And anyone tell me what you remember, if anything, about the kidney heist? Ice bath, a tube, and I see drink got spiked, a friend of a friend, tube in his back. Okay, good, excellent, thank you. Kind of indicating that that some of it sticks, right? Some of it stayed with you. Probably don't remember too much else I said, but maybe you remember that. And so thinking about what you know now about Made to Stick, I know that for some of you, you haven't really gotten into it yet, but why do you think you remember it? What qualities about that story make it stick with you? Anyone enter anything into the chat? Okay, good. Lots of entry here. So unexpected, yeah. This unexpected, shocking thing that happens to this poor guy who goes to a conference in Atlantic City, and he ends up in a bathtub full of ice cubes without his kidney. So yeah, it's unexpected. It's concrete. There's vivid detail. There's the ice cube bath. There's the tube that's connected to his back. It's kind of emotional, right? It's kind of shocking. It grabs our attention, and it's also it's based on a story, right? It's telling us a story, and so there's a number of factors that come into play that are very, very centrally connected to Made to Stick. And so I wanted to see if in fact some of you did remember it. So I'm very very impressed with that. And so I will go to my screen to the text itself, to Made to Stick, and I was looking back at the introduction to the text today, and I noticed one of the guiding questions that the Heath brothers present for the text, which is what makes some ideas stick and others disappear. And kind of a very good question for any of us interested in communication. You know, what is it that makes our ideas memorable? What can we do to make them memorable? So I think for all of us, this is a very a good question to be asking about all of our communication deliverables. In terms of the course here, we're really responsible for introduction chapters 1 through 6. There is an epilogue and a few after pieces that you can certainly take a look at, but we'll be focusing on the introduction chapters 1 through 6. And I'd recommend that you pick the text up probably through Kindle. It's available for $11.99 Canadian on Kindle, and you'll need an Amazon account in order to do this, but because the libraries are closed, we really don't have access to the text through the library so easily. There's no e-copy available in the UT library system. So my best advice would be the ebook on Kindle. Excuse me. You'll want to be familiar with Made to Stick for the January 20 lecture. I'll be in next Wednesday, and I'll be basing a lot of the lecture on Made to Stick principles. And you'll certainly need this text for written document O, which is due on January 31. And you want to really be familiar with it for all the communication deliverables in the course. And as I said, Kindle is probably your best bet. You can get a hardcover for $28, a paperback for $25, the Kindle for $11.99. I would avoid some of the summaries that you'll find on the internet. Many of them are kind of incomplete, sometimes somewhat misleading. And so I would not go to those in lieu of reading the book. There's a couple of them that students in the past have relied upon, and they didn't do so well on written document O because they presented information that didn't seem to be connected really with what the Heath brothers, the authors of Made to Stick, have presented. A few recommended texts. We've always included these in the past on reserved reading. We don't have a reserved reading list from the library, but this one, Style by Joseph Williams, is available on Amazon paperback for just over $12. And I like this quotation here. What counts is not the number of words in a sentence, which, draws our attention to concision, but other factors that are maybe even more important. How easily we get from beginning to end, how we navigate through, and more importantly, while understanding everything in between. And this reminded me of a presentation a few years ago here in ECE 297. We had a guest speaker, Will Greenblatt, who has background in theater, and he now works as a coach for giving professional advice for professionals, could be academics, people in industry. He gives a lot of advice on oral presentation. And as he presented to the 297 students, what he sees to be the golden rule in communication is make them care and make them understand. And that seems to be very connected to Made to Stick in my mind. And William's emphasis here on making sure that you make your audience understand is kind of key to any communication. Another text that I find kind of very useful is Steven Pinker's The Sense of Style. Pinker is a cognitive scientist, a linguist, and his advice for writers, I think, is equally good for those giving presentations. And like Williams, he kind of focuses in on the importance of making your audience understand. And his statement for us to go from, I think I understand, to I understand, we need to see the sights and feel the motions. And so drawing attention to how important it is as communicators that we use concrete sensory kinds of detail in our communication. So again, very much in line with the Made to Stick principles. Lastly, Daniel Kahneman he's a professor of psychology, and his study kind of outlines two systems of thinking, one that's very fast, that's instinctive and emotional, and a second system that's very deliberate and logical. And Kahneman's thesis is that we often make poor judgments because we kind of overestimate how much we know about the world. And so he uses these two systems of thinking to kind of put forward that thesis. And that idea that we tend to overestimate how much we know about the world is, again, I think, connected to one of the points Professor Betts made yesterday in relation to Made to Stick, around the curse of knowledge, that we know more than those who we are communicating to, and it interferes with our ability to communicate effectively. And this is kind of a nice quotation from Kahneman, that the confidence that individuals have in their beliefs depends mostly on the quality of the story they can tell about what they see. And so drawing attention to the importance of story, of being able to tell a story with conviction, again, going back to the made to stick principles. So I just wanted to, kind of give you a few texts that, even if you don't look at them this term, they're always there for you, these recommended texts. A made to stick, of course, is required. So we want you to have that, with you for next Wednesday for the lecture. And I just thought I'd spend a couple minutes with you. Yesterday in lecture, you did a little breakout activity. Professor Betts had you working on trying to describe what ECE is in one sentence to the general public, maybe to your Uncle Larry, who's not so knowledgeable about ECE, and came up with lots of interesting kinds of approaches to that. And here's a few that were in the chat that you yourselves came up with, and I'm curious to see what you think about these. Just as quick kind of responses, do you think these are going to be effective for Uncle Larry, or what do you think? Let me just draw up the chat here. I think our Uncle Larry will understand that we are sorcerers, which is true. Yeah. And, I kind of like this one. I think Professor Betts did as well, because it's kind of unexpected, right? It certainly gets our attention. And that might be a way to get Uncle Larry, kind of at least interested in what it is you do. The first is false. Okay, you think. The last one is okay. The second one, we use computers and electrical machines to create things that people would otherwise not be able to create. Maybe not so simple, not so concrete here. What kinds of things are these? Would the general public, would Uncle Larry know what that means? So again, being kind of more specific might make the statement stronger. ECE is the foundation of knowledge that governs and connects every aspect of the modern electrical and technological world to the general population. Kind of has a nice aspirational tone to it, but probably not so memorable. Probably couldn't be able to, in 5 minutes from now or even 2 minutes from now, go back and remember exactly what it is that's being said here. And maybe that's because it's at a kind of an abstract level, right? There's not any specific concrete or concrete enough detail that makes it memorable. So those might be a few things that I would observe about those. But nice, I guess one of the things we see is how difficult this task is. Something that might seem easy to do, actually quite difficult. Just quickly on team values, I know that Professor Betts talked yesterday about team, and I think I've seen that there's close to 80 teams now are registered. So that's showing that most of you have already made decisions about this. And so you've obviously made some, you've had some criteria when you've made these decisions. Maybe it's friends you're choosing, people you've worked with in the past. And I'm thinking that you'd be wanting to think about what values are important to you when you work with someone. And there's a number of things that come to mind, and these could be qualities that are important for professional kinds of teamwork, or even in more personal kinds of relationships. These kinds of things are, very fundamental to creating a functional, workable kind of relationship. And it's respect, I guess, is something that all of us are wanting, I think, in work we do with others. But to be concrete about this, how does someone show respect? How do you know that you are maybe being respected or being respectful? And a few of the kinds of actions that you might consider: someone who's respectful listens to others' ideas, apologizes when he or she lets the team down, someone who arrives on time, gives others credit for their contributions. So there's lots of ways that we can think about, kind of looking for this, but also showing, in this case, respect to others ourselves. Accountable. What do we do to make ourselves accountable? We take responsibility for actions. We leave a clear communication trail. We don't make excuses for mistakes that we might make. So you'll see here there's a number of different kinds of values that you might have. And as you start to work with your team, being able to discuss some of these in concrete terms, I think will be important to ensuring that you come up with a kind of a charter for the team that will ensure that you're productive through the term, that you've got common goals, that these common goals are not simply at an abstract level, but you've come up with some concrete ways of being able to see that you're actually doing these things, that you're being respectful, that you're being ethical, these kinds of things. So we'll be discussing this once you are kind of moving forward in your team work, but it's something early on here that you might want to be considering even now, and particularly for those of you who have not yet formed your teams, that these might be some of the things you want to think about. So Vaughn, I'll stop here and let you go to your slides.
Sure. Ken, I saw one question in the chat at the end there of, are the darker traits more important? Why are some traits gray and some traits black?
If they were, I think I was just highlighting a few to discuss in particular. So all of them were gray initially, and then I just chose a few. I think I chose respect and accountability. So I bolded those just as we were discussing them.
Okay, sounds good. Let's see, there's another question about, will we be doing peer reviews like an ESP?
Yeah, and I think we will. That's the plan. And with the remote kind of presentations we'll be giving rather than in-person live presentations, we might be a little bit challenged to do some of the peer review work that we haven't done in the past. But it's my objective that we certainly include it as we're able to.
Thanks. I think that's all the chat questions.
Okay, good.
Okay, so I'm going to talk about version control and Git, which is going to be, one of the foci of milestone 0 is getting you used to source code control or version control, and the Git system, which is probably the world's leading source code or version control tool now. Okay, so why do we need this? Okay, so version control is intended to solve several problems. Let's start by looking at what are those problems so you can understand why you have to do this. So say I've got a program and it's got 2 CPP files and 2 header files. And let's also say that it's not me coding this, it's Tony Stark. Keep it interesting. Okay, so he's editing file 1.cpp, makes some changes, okay, saves it, and builds, because you should always build after you make a change, test. Okay, so Iron Man's a good coder, that's what he does. But sometimes, you make a mistake. So your program is now broken. What do you do? If you just made a small change, so I made one change, that's not a big deal. I know what I did. I'll go back, look at it. I can undo my change because I still remember it. But what if I made a whole bunch of changes? And only after that did I figure out that it's broken. This could now be really painful for me to figure out which change caused the problem. Okay, so we need a way to go back to a previous version of the program, because this happens all the time. You're making a change, you think it's a good idea. Sometimes you might change a lot of things thinking you're on the right track to something better, and it turns out no, it's gone off the rails. You want to go back. Maybe back to a version that you had quite a while ago. Okay. Is there any simple solution to this? So, maybe we don't need version control. You don't want to learn Git. What can we do to solve that? Okay, undo. Yeah, so you could use Control Z if you've got one file and you haven't saved it to disk, and you can hit Control Z many times. It doesn't scale very well if I'm editing a program with 30 files, and I might have been editing it, making changes and compiling for the last 2 days before I figure out I got a problem. I could keep an older version of the file, so that'll work. And that is actually what people do if they don't have a revision control system. They basically copy all their files to another directory every once in a while. And that will work. Okay. So make a copy of all the files. And I don't know when I'm going to make a mistake. I don't know what how far back in time I might have to go. So I might have to keep these for a long time, and I should make a copy pretty often. Whenever I do something wrong, I switch to that backup copy. But there's some problems with this. So those problems are, how often do I copy the files? If I do it every 5 minutes and I keep them forever, this could get pretty big. If there's a problem, it might be hard for me to figure out which backup copy I should go back to. I think I've introduced a problem, but I don't know when. Maybe it was maybe it's 2 weeks ago, but I'm not sure. I might have to do a lot of manual work to try to figure out which backup to go back to. And people forget to do this. If it's not automatic, then you're going to forget to back up. You're going to feel good someday and be coding like crazy, and then later on realize, oh no, it's gone horribly off the rails. So that is the low-tech solution to it. People use it, but it's not the best. Okay, let's look at our second problem. So our second problem, same program, 4 files, right? I've got Tony Stark editing one of them again, but it's a bigger project, and he's got to bring in Batman. Okay, so Marvel and DC have now unified. It's one big franchise, and they're collaborating on some code. And they both edit this file at the same time. Okay, so Tony saves it, then Batman saves it, and when each of them builds, they find that, Batman's happy, but Tony Stark finds his changes have been overwritten. Okay, so he lost his changes. There's some chaos happening here. They're both editing the same files at the same time, so they can overwrite what the other person is doing. Okay, so we need a way to stop this problem. We have conflicting edits to a file. Most significant programs are written by teams of people, so you've got to have a way that they can collaborate where they don't overwrite each other's work. Okay, so any simple solutions to this? The simultaneous editing problem. Again, maybe we'll find out we don't need to learn Git. We can just use something else. Okay, so I see people saying Google Docs. So Google Docs, yeah, multiple people can edit in Google Docs. That sounds like a reasonable idea. Make your code modular, use lots of CPP files. That's also a good idea. If you break it up into many files, then it's less likely you're both editing the same files. That is a good technique. Have a Zoom meeting and work together. Could do that, but it doesn't, and that actually works at the small scale. You do that sometimes, but it doesn't scale well when you have lots of people on the team. Okay, so, but these are all reasonable ideas. Okay, so let's keep going on some of them. So one of them, which I don't think anybody actually mentioned, but it's like email everybody whenever you start editing a file. So basically, you could break your program up into many files. That's an idea people had. Now there's less likelihood you're both editing the same one. Email people when you're going to edit that file. And then when you're done, you send another email. Okay. This is actually how early source code control systems work. They didn't use email, but they did what's called locking. So this is basically locking a file manually with email. You're saying, I'm taking this file, nobody else touch it. But there are a bunch of problems with it. Maybe I didn't read the email. Maybe we both send an email at the same time. So we each start editing thinking the other won't. So it's not perfect. And it doesn't scale well to many developers. As you have more and more developers all emailing each other trying to say who's editing what file, it turns into chaos. You could use a Google Doc, as people suggested. It's better, But it also maybe gets slow if you have huge numbers of people editing it. Also, you can still lose edits with Google Docs. They just tend to be much smaller. It's updating very frequently, but you might be editing a line while someone else is also editing it, and you're undoing each other's work without realizing it. So Google Docs probably the best of these solutions, but still not perfect. I see someone suggesting other source code control systems like SVN. So SVN is kind of like Git, so that's another source code control system. All right, so that was our second problem. Multiple people editing the same file. Third problem. Okay, so again, we've got Tony and Batman. They're both editing files. They're editing different files. Okay, so that's fine. They're not going to write on top of each other's work. Each of them makes a save, and there's no conflict, right? They didn't overwrite each other's changes. Then they go and build. And what they get is, they don't get the red program that would be Tony's changes. They don't get the green program that would be Batman's changes. They get something that's a mix of the two. And this actually is exactly what Isidore is commenting on in the chat. When they go to test their changes, they're actually texting some bizarre mix of their changes, which neither of them expected and which is actually not very likely to work. So they didn't overwrite each other's changes, but because a program is bigger than one file, they've incorporated changes from the other without realizing it. So it's a big mess. And there'll be lots of recriminations. So we need to control when our changes become visible to others. It's not enough just to make sure we don't lose any changes. You spend more time in programming, testing, debugging, figuring out if it's all good than you do actually writing the code. So we need a way to write some code and then do our tests, do our thinking, and when it's all in a good state, then we release it to the rest of the team. Not they're seeing our changes as we make them, and they're simultaneously trying to make changes. And I actually don't know of any good solution to this one. Like, I can't actually think of a good, simple solution to this, so I'm not even going to try. Okay, so these are the reasons. Those three fundamental problems are why people invented version control systems. And the version control system we're using in this course is the one that has become the most popular in the world. It's called Git. And you may have heard of GitHub. GitHub is built on top of Git, basically a graphical user interface and some extra tools. There are many other tools built on top of Git, so it's kind of more fundamental than even GitHub. And there are good reasons why it's become a dominant source code control system. It has a lot of very good technology in it. Okay, so how does it work? So the key idea is that you have local copies where you write your code, you build it, you test it, and you have a global repository that you use to keep old versions of the code and to share with the rest of your team. Okay, so some terminology. Both Iron Man and Batman now have their own working copy. Okay, so this working copy is, two completely different copies on their own machines. So each of these is on their own machine. They use Git commands. Sorry, I should actually circle the files rather than circling the people. So they've got two completely different copies of the code, but they can send versions of that code to this central repository. So they use Git commands to send changes into a central repository and to take changes out of that central repository. And because both of them can talk to the same central repository, that's how they can exchange information. They can make the changes visible to each other, but they can do it in an orderly fashion when they're ready. Okay, so let's look at how this solves our problems. So problem 3, we're going to reverse order here. Controlling when my changes become visible to others. Okay, so what you do is you work on your own working copy. So Tony's got one version and Bruce Wayne's got another, and you can change it, you can build it, you can test it with no interference from others. Okay, so Iron Man makes a change to a file, so I'm showing that as red here, builds, tests, looks good. Okay, same time, Batman makes another change to a different file, it's green, builds, tests, also looks good. So they're not in each other's way. Now they're both happy with their changes. They want to put them back into the repository, make them visible to the rest of the team. So when each of them has finished and fully tested a change, that person does a two-step procedure called commit and push. Okay, so they use two Git commands to take those changes and get them into the central repository. So it's like publishing them. Okay, so you run the command git commit and git push. And what happens is that red file goes into the central repository. Same thing for Bruce Wayne, git commit, git push. That change to that green file will go in the central repository. So now they've been integrated together, but at a controlled time, when each developer asks for that integration. Okay, now you can take things out of the repository. So, and that's done with a different git command, git pull. And in this course, we're not teaching you every git command. There are a lot of options, a lot of git commands. We're teaching you the key ones. So we're recommending that you do git pull -r. The -r is just an option that integrates the changes from the central repository into your working copy. So in this case, we took the green file and we got its changes into your working copy. And it does it in a way where it's easier to understand the history of how the file's changed. So it's just an option that changes how this pull works a bit. And we recommend that you always use that option. Okay. And they both do this and they both get each other's changes. So after each of them has done this, they can see the latest code from the repository. But again, each of them chose when to do that. So they decide when to put their changes back for others to see them, and they decide when to take changes from others. And this basically just repeats what I've already said. Okay. Now, whenever you do a git pull, you're getting changes from other people. And it's possible that those changes plus the changes you've made in your own on your own code don't work together. Okay, so after you do a pull, you should always rebuild, always retest to make sure. Okay, I got some changes from other people. Let's confirm it's all okay. Because if not, I want to know right now, so so that I go bug the rest of my team rather than I don't notice this for a long time and I have no idea what's happened. Okay, so you build this tests. Each of them builds and tests. If there are problems, there are integration. Those are called integration errors. So there's some problem with how the fact that both of you changed the code integrates at a functional level. You want to fix them right away. It's also much easier to fix those integration problems if you integrate often. So you try to break your work into small pieces. I want to get a certain amount of new functionality done. I want to commit that. I want to push that. The rest of my team can see it. And they're doing the same. So we're constantly integrating little changes. So if we have a problem, we know it's not in a huge list of changes. It's very hard to sort out. So I try very hard to do this. What I often find is in this course is that many teams will try to work relatively independently. I'm just going to write lots of code. I don't want to commit it. I don't want to push it. I don't want to bother my teammates. And then the day it's due, we're all going to try to put our code back together and it should all just work. And usually it doesn't all work and it's a really stressful situation. So doing it with constant integration of small pieces, much less stressful. You don't get surprises at the end. Okay, so that was problem 3. What about problem 1? Problem 1 was we need to be able to go back to a previous version of the program. Okay, so now I was oversimplifying this repository a little bit before. So let me show you a little more detail. This Git repository doesn't really store just one version of your code. It stores all the versions that have ever been committed and pushed to it. So we've got some initial code and we'll call that revision 1. Okay, so Iron Man does a commit and push, puts some new code in, and the change is this red file. Okay, so that new revision has that red change in it. A little while later, Batman does a commit and a push, and the change is this green file, and that green file goes into the repository. But each of those commits creates a new revision. Okay, so I've now got 3 different revisions. I started with R1, changed to R2 when Tony Stark committed, changed to R3 when Bruce Wayne committed. They all exist. So if there's a problem, I can still get those old revisions out. I can look at what changes were made. I can get the old versions. I can go back to it if I have to. Okay, so let's say this happens, and both of these commits and pushes happen, and then Iron Man does a pull to get the latest code. So when he does that, he's going to get this green code coming into his working copy. As soon as you do that, you should always build and test to make sure it's all good. Okay, same time Batman's doing the same thing. Okay, and this last revision has a nickname. Okay, the last revision is called the head revision. And when you do this git pull dash r, that's what you're getting changes from. You're saying, go look at this head revision, essentially the last revision, and whatever changes are in it that aren't in my local copy, bring them in. And yeah, the question of, do you always pull before pushing? Yes, you do. And if you forget to do that and somebody's made a change, Git will tell you. So it'll say there are changes and you haven't done a pull. So if you forget to do that, you're going to get told to do it by Git. Okay, so let's say Iron Man does this pull, builds, tests, and it fails. Okay, so that's the unhappy situation of some changes made by Batman, broke the build. Doesn't work. And he thinks this is Batman's problem. Okay, so I pulled Batman's changes in. I'm failing tests. I think that was his fault. How do I prove it? Well, he can check out and test an old revision. So he can actually use git commands to see, okay, that was put there by Batman. I'm going to get the revision before that. That's the last change before Batman's changes, or last revision before Batman's changes. And you do that with a command called checkout. So git checkout. The way git works is, the program is git, and then it always takes a command after its name. So git checkout is the command checkout given to git. And you have to say which revision. So I say, I want revision 2. So I want to get this, even though it's not the last version, I want to get that one. Okay, so he gets that last version. His code now looks different. Those green changes are not in his working program or working copy. He builds, he tests, and it passes. Okay, so now he's got strong evidence. Revision 2 works, revision 3 is bad. The problem is in the revision 3 changes. And he can say, I need Batman to go fix this. It's Batman's problem. And okay, so actually, it's a good question. Someone's asking, do the numbers increase chronologically? The real numbers are actually long. They're actually hashes. So they're not nice integers like this. It's not R1, R2, R3. It's like a long hexadecimal number. So you actually use git commands to say list the revisions, and they'll be listed in order, but they'll all have long numbers as their names. And then when you want to do a checkout, you have to type the first part of that number. Okay, so I've kind of simplified it on the slide. It is something like SHA 256. I forget exactly what hashing algorithm it is, but I think that's the right one. So I'm answering chat questions at the same time. And one gotcha that sometimes students have with milestone 0, because we ask you to check out old versions of the code to be able to show them to your TA, to show your TA, oh, here's what I did, and here's what happens with this old version. Here's what I did to fix that in this new version. So we ask you to check out various versions of your code when you're demoing to your TA. You cannot update, that means commit to an old version. So if you want to actually do a commit, you got to do a checkout of the head, the last version. So you can check out old versions, you can compile them, you can check out you can see what's going on, but you can't commit to them because, well, then Git wouldn't know what to do. Like you're trying to make a change here, but there are changes after it. So it won't let you do that. Okay. All right. So let's say Tony Stark has now proven, though, that R3 is bad. Okay, so he does this command, git checkout master. So that means get me the last version again. I know it's broken, but I got to get the last version because I want to make updates. And master just means basically the tip of the commit change, the last thing that was put in there. He knows that this R3 was bad, so he wants to get rid of it. And there's actually this happens often enough that there's a command for it. So we say git revert R3. So it basically says undo R3. Whatever changes were in there, do the opposite of them. Okay, and then he pushes to the remote repo. Okay, so he reverts. He builds, he tests, he shows it works, and he does a push to put that back in the remote repo. And now basically the last revision, which is the head revision, is basically fixed, but he did it with this kind of two-step procedure. Okay. Let's see. Now, how do you see all these changes? Because I said, well, graphically here, you can see there was revision 2 and revision 3. Use git log. So git log tells you all the commits that have been made. What are the files that are changed in each one, and the message for each commit, and you should make those messages meaningful. That those messages help you figure out oh, something went wrong, who did what. And this is going to be part of your style mark. There are a few marks in each milestone for style. Your TA is going to look at how you use Git. Did you actually make a lot of small commits, which is good practice, or did you make one huge one at the very end? Did you use meaningful messages so people can figure out what you were doing or not? So follow these practices. It's good coding style in a team. Okay. Yeah. So if you're trying to figure out what went wrong here, use those terms, those that Git log to see what are all the commits that have happened. Now you still might not remember. Okay, I can see I made a commit to make this revision 3, but I don't remember exactly what I did in that commit. My message says I made some changes, but unfortunately I didn't write it in great detail. There are commands in Git to see what the changes are. So for example, I can type git diff revision 2 and revision 3. So that basically says, show me the changes between those two revisions. And what that would output is something like this. And you're going to see this in milestone 0. So don't worry if you go, oh, that's a lot of syntax, I'm not going to remember all that. The whole idea of milestone 0 is you start practicing with these tools so you get used to what their output looks like, and you gradually get better at reading it over time. So this output is saying that file 2 is different in revision 2 and 3. That's what the first part says. It says the differences come after line 192, which is in this function, superhero setup. And the changes are going to have pluses for additions and minus for deletions. So basically this green line was put in by Batman. So basically it says the best superhero is Batman. And this purple line was in the old version, revision 2. It was Iron Man was the best. So this output basically is showing you which files changed. That's what's up here. And then it shows you in detail, okay, which lines changed between these two revisions within this file. And those changes are those are the lines that have these pluses and minuses in front of them. Okay, so by looking at that, you can figure out, okay, here's exactly what happened. It's failing tests, so I think this is the problem. Let's go try changing those lines back. Let's fix this. Okay, so I saw some questions in the chat about, doesn't it still take lots of storage? And no, you only store the changes between revisions. So Git is smarter than just storing a copy of your whole project every single time you make a commit and a push, because usually you only changed a few files. It's again, and that's what we're recommending. If you're actually changing all the files and making huge changes, then that's usually showing a bad team-based coding. So the changes are typically small. So even if you store all those changes, your repository doesn't get that big. Okay. Can you use Git for Quartus projects? Yeah, you can use, and in fact, so this is a good question. Git is used for more than just software. So, I mean, modern hardware design has a lot in common with software. So you use revision control systems like Git, or Git is a very good one. So that's actually the one I'd recommend. And basically, you can take all of the inputs to a tool like Quartus, a hardware design tool, and they're text files. They're really no different. They're not very different from C++ files. And you can check them all into Git. And that's actually what teams designing hardware do as well. So, okay, so those are two of our problems. The last problem was problem 2. What about conflicting edits to a file by different people? There are 2 basic approaches. The first one is lock-based. This is kind of like our email system, but more organized. Basically, before you edit a file, you have to enter a command to the revision control system saying, give me a lock. And only after you get that lock will allow you to edit the file. And nobody else can get that lock while you hold it. When you're done editing, you tell the revision control system, I'm done, and it releases the lock. And this is actually how the first generation of revision control systems worked. They're called, these are tools like RCS and VCS, so you might still hear of these. Don't use them. Friends don't let friends use these systems. They're nowhere near as good as the modern ones. And the modern ones are merge-based. Okay, so merge-based means instead of preventing edits that could conflict, that's what lock-based does. It makes sure only one person can edit a file at a time. Merge-based ones are more sophisticated. They actually just say, they're kind of more like the Google Docs approach. We'll let multiple people edit a file at the same time. They can each edit their own copy. And only when they do commits and pushes do we try to sort out what changes we should put back. And Git uses this system, and another revision control system that's popular called SVN also uses them. So all modern systems use this technique. Okay, so how does that work? So uh, let's go through our example again of Batman and Iron Man are both making changes. And a little more detail, your working copy, Git actually knows what revision from the repository it's based on. So it stores a bit of extra information. So it doesn't just know these are all your source files. Okay, that's what you need to compile and test them. It's got a little extra hidden information that says those source files actually came from revision 1. You've made changes since then, but that's what they were based on. Same thing over here. Okay, so Bruce Wayne, we also know that his code is based on revision 1. Okay, so now Tony's made some changes. He does a commit and a push. We get revision 2. Okay, we've already seen that. Bruce Wayne does the same thing. He's actually going to get this message. He's going to get a message that says can't do fast forward merge. Kind of not the most user-friendly message, but it basically means you need to do a pull. All right, someone else has done a change. It's not in your code. You're based on R1, and the repository is already up to revision 2. I'm not going to let you do a commit. You got to do a pull to get those changes. Okay, so Bruce Wayne does a git pull -r, get the new changes. They get integrated into his working copy. And actually in git updates, okay, now I know that you're based on R2. Okay, he builds, he tests, it all works. Okay, so he should always build and test. He's got to build and test at this point to make sure it all works. If it doesn't work, he's got to fix it. But it works. So now you can do a commit and a push, and it will go in and produce a new R3. Okay. So that was the case where Iron Man and Batman edited a different file. What if they modified the same file? Okay, so notice now they've both changed the same file. All right. Tony puts his change back first. Bruce Wayne gets the exact same message saying you got to do a pull because there's been an update since you got your revision, right? We're at revision 2 and you only based off revision 1, do a pull. If Tony Stark and Batman modify different lines in the file, Git is smart. It basically looks at what the changes are compared to revision 1 in each of these, and it combines the changes. So as long as they edited different lines, it's actually fine. It'll come up with the changes to the file, put them all together, and Batman could then commit and merge. The unhappy case is when they both change the same lines. Okay, so these lines that were changed by both of them, Git cannot figure out what you want. All right, so it just can't figure it out. So, and what happens then is it basically says there's a conflict and it writes out information in the file. So in that file, which was, if you go back here, well, okay, let's say it's file1.cpp. So in file1.cpp, this is what was there originally in the repository. And after this sequence of commands, Git will say, well, there's a conflict. I can't figure out how to put all these changes together, but it'll put conflict markers in this file1.cpp, and they look like this. This is called a conflict marker, okay? This is a conflict marker. This is a conflict marker. What do they mean? It's basically telling me that this code here is what was in Batman's local copy, and this code here is what was in the repository. And it can't figure out, those two lines have been changed. One was changed by Tony Stark, one was changed by Bruce Wayne. It's the same line. It doesn't know what to do. It's showing you these are the two versions of this line I have. You got to decide what to do. Delete one of them, delete both of them, merge them somehow, saying Batman and Iron Man are both the best, whatever, but it can't figure it out. And you also get rid of these conflict markers when you're done. These are just to highlight the conflict for you. They're not obviously C++ code, so you got to get rid of that. So you have to edit this, get rid of the conflict markers, make the code make sense again. And then there's another couple of steps. It's in the Git quick start. I won't go through all the details, but this will happen to you at some point in this project. So just follow that to see how you do it. Okay. Resolving conflicts is kind of a pain because I already wrote the code and now I got to go in and I've got to figure out how to integrate it with my teammates who change the same lines. You minimize the chance of this happening if you commit and pull often. And if you And if you also communicate with your teammates about what you're doing and what they're doing, because this is not a big thing to panic about, but it is kind of wasted work. Okay, I think I'm going to stop there for today. We Well, let's see. What would you guys prefer? Do you prefer I just finish the next couple of slides so you're further ahead on milestone 0, or would you rather I stop now and just continue on Wednesday? All right. So I see a stop. First person said stop. All right. It looks like it's a split decision. All the slides are on the website. So I'm going to stop here and we'll finish up on Wednesday. But you can read ahead, and we're through most of Git. We're just on to a little bit more. So go ahead and read ahead if you want to be sure you know everything that you should know before you do milestone 0. And I'll hang around again if there are questions. But yeah, we're done for tonight. Have a good dinner.